Hello, and welcome to today's seminar. It's the first in our Smart Mobility Connection series for the fall semester of 2020. My name is Lisa K. Schweier, and I am the Program Manager for Traffic 21 and Mobility 21 University Transportation Center. The Smart Mobility Connection series is sponsored by us as an opportunity for faculty to showcase their current transportation projects. It's also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note, the session is being recorded, and all participants' microphones are muted. To ask a question, simply send a message through the chat box, which should be located at the bottom of your screen. You do not need to wait until the end of the presentation to send your questions. Please do so as they pop into your mind. So now I'd like to introduce you to today's speaker. Dr. Megan Ryerson is the UPS Chair of Transportation and an Associate Professor of City and Regional Planning and Electrical and Systems Engineering at the University of Pennsylvania. Since 2018, she has served as the first Associate Dean for Research at Penn's Weitzman School of Design. She is the Research Director of the Mobility 21 Research Center and the founder of the Center for Safe Mobility. Dr. Ryerson leads a large, diverse, and active research group focused on developing data-driven methods to investigate pressing transportation problems, including changing mega-regional travel trends in an era of new vehicle technology, and quantifying transportation safety in an increasingly multimodal urban transportation system. So I'd like you to help me welcome Dr. Ryerson as she's going to tell us about building novel traveler-centric metrics to design safe and efficient transportation infrastructure systems. Dr. Ryerson.
Great. Hi, everyone, and thank you so much, Lisa K. and Joy, for having me and setting this up, and thanks everyone for joining. Once the screen share is enabled for me, I'll go ahead and show you my screen. Okay, great. Great. As Lisa K said, I'm Megan Ryerson, and I'm the UPS Chair of Transportation at the University of Pennsylvania with appointments in both city and regional planning and electrical and systems engineering. And my title is very long, and what it really boils down to is that in studying surface transportation, in studying intercity transportation, in studying air transportation, global transportation, I'm focused on authentically representing travelers, individuals, their microbehaviors, their macro behaviors, and so on, and turning their behaviors into quantitative models and integrating that into our planning processes. So that's what I'm going to talk about. That's what I'm going to talk about today. And the questions that motivate my research that I'm going to talk about today are: how can and should we design safe urban transportation infrastructure for pedestrians and for micromobility travelers? Given the lack of predictability in our future, and certainly that's where we're all sitting today, are certain long-term transportation plans and investments worth it, right? How do we make 30-year, 50-year investments today when the future is so uncertain? And finally, what are the gaps between our intercity planning processes and institutions and the way we actually travel, right? And what new methods and perspectives might be needed to integrate how you and I actually make travel decisions into our current processes? And so, sort of more methodologically, what I do is measure quantities like travel or microbehavior, more macro travel behavior, preferences and of suppliers, of operators, of transit suppliers, of airlines, of shippers, and so on, and develop quantitative techniques to integrate this user, supplier, operator perspective into behavior. And I do this to develop new metrics of safe and accessible urban transportation, to develop new insights and use and sort of modify existing techniques to plan for the unexpected, to plan to predict and recover from shocks in the transportation system, and to integrate rail, highway, surface transportation, and air transportation planning into one framework such that we can capture the way that people really travel in our planning processes. So I'm going to start by talking about my research on safe, accessible urban transportation and new metrics for that. I'm going to move into the planning for the unexpected, and then I'm going to wrap up with planning for network-based intercity transportation planning. Okay. So starting with safe and accessible urban transportation, how I really got into this field was, studying the status quo of how planners and how our deployment partners conceptualize and measure urban transportation safety. So many of you are likely familiar with things like crash hotspot maps and so on. This is the map from the Philadelphia Vision Zero plan from our deployment partner Otis. And what's shown here are sort of hotspots of injuries and traffic-related deaths. And then Otis and their partners developed what they think of as the high injury network, right? And very commonly, these are the maps that are used to identify where intervention should be placed, safety intervention should be placed. However, I argue that these maps are an imperfect picture of safety, right? We know that crashes are underreported. Biking in Philadelphia for 10 minutes, that there are near misses regularly that, could have been a crash, but, someone caught themselves or veered or so on. Also, we know that people avoid unsafe facilities. There are two intersections on the walk that I could take my children to school. One of the intersections has very low sight visibility for drivers, and people routinely speed, so I don't cross there, right? So a crash can't happen if people avoid the intersection, but that doesn't mean it's unsafe. There's also very incomplete information on sort of the types of crashes and the characteristics of people involved in the crash. And the existing way that we think about safety with hotspots is really not useful to evaluate the effectiveness of a countermeasure, right? So a crash hotspot map tells us, or possibly tells us where we need countermeasures, but it doesn't tell us the effectiveness. And so what are good measurements of safety, right? How do we collect this sort of safety data? And so building on this concept of authentically representing the user, my team and my lab are coming up with sort of brand new ways to measure urban transportation safety. And I should say brand new ways that are very grounded in traditional ways that we as transportation planners and engineers think about things like highway safety and driver safety, but have never thought about it for pedestrian and cyclist safety. And so what my team is doing is capturing authentic micro-mobility, pedestrian, traveler behavior using eye tracking glasses. We have a set of eye tracking glasses that collect 100 times per second eye movement, gaze location, pupil position, head movement, and also video and audio files. So people can actually narrate their trip as they're taking it. And we've had subjects bike and walk in different facilities in Philadelphia. We have a number of different test sites. The one I'm going to show today is on a brand new protected cycle lane on JFK and Market, sort of in this heart of Philadelphia, connecting close to City Hall. You can see these two pictures of different facilities, or I should say different characteristics of the same facility. Here where we have bollards protecting this bike lane, we call that a protected lane. And here where we have just paint and no separation from the traffic, we're just going to call that an unprotected lane. The lane exists, but it's not physically separated. And so we have people cycle this, oh, excuse me.
We have a question.
Sure.
Should hotspot maps be differentiated between car crashes versus car bike and car pedestrian crashes?
I mean, any level of disaggregation I think is useful, but we still have the same issues of underreporting, of near misses, and of avoidance. So I think my motivation is really to come up with proactive measures to metrics to study safety rather than reactive, you know, here's the data that have been reported, and really to come up with, before crashes occur, how can we identify facilities, the exact locations that might not feel safe, and also come up with a more quantitative method to evaluate the change in the perception of safety when an intervention is put into place. So we had subjects bike up and down this particular facility, and you can just see the sort of difference in before and after the cycle lane is on the left side of the street, and in some places it's bollard and also parking protected, and we sort of plotted the results for the eye movements and the head movements. And so what you're seeing here are all of our participants, basically the range of their gaze, when they're in a protected lane and when they're in an unprotected lane. And then we did, you know, a number of quantitative statistics on this, and we just found that when subjects are in an unprotected lane, the range of their gaze is very big compared to when they're in the protected lane, and just sort of indicating that their workload, the amount of work, the amount of information that they have to take in at a particular time is much, much higher in an unprotected lane. We know that the amount of workload that a person has can lead to feelings of unsafety and sort of the inability to take in even more information. So then we took a look at head movements, sort of gyroscope movements, and we plotted them based on infrastructure. So you could think of this as you checking over your shoulder to see if, if there's a vehicle over your left or your right shoulder. And not surprisingly, when our subjects are in protected lanes, their gyroscope movements, their head movements are significantly tighter and less frequent. And when our cyclists are in conflict zones or unprotected zones, their head movements are on the much more sort of extreme measurements. And again, we can picture what this is like. They're checking for traffic. But what this indicates is that in an unprotected zone, the cyclist has to have a much higher workload, right, and take in a lot of different information. Normalizing for the fact that every cyclist is different, we did quite a bit of data work and normalized each of our participants and sort of parsed out their top 1% movements, and then we plotted their top 1% movements. And for all of our variables, movements, head movements, over the shoulder, head movements up and down, the amount that your eyes have to move around to take in information, the speed at which your eyes are taking in information, all of these peak in unprotected zones and are significantly tempered in protected zones. And you know why my team and I think that this is so promising is that we can develop almost trajectories of multivariate stress levels and workload levels because we know that when workload on all of these different measures are high, that it's very possible for someone to make an error. It's very possible that if your workload is already very high and a vehicle sort of swerves into you, that you won't be able to react as fast, and that we have this new sort of multivariate understanding or new multivariate perspective on safety. Now, this is a pilot. We had about 35 subjects, and we're still parsing out the results. You know, working on the data analysis, working on the data science of this. As you can imagine, we haven't been able to send out more subjects recently, but we think that this is a very promising, I'd say, additional dimension from which we can evaluate urban transportation safety. We're also doing what I think are some really fun things with our deployment partners with this research. With our eye tracking glasses, we can answer the questions, you know, do cyclists or pedestrians see this sign? You know, this one particular sign on Chestnut Street follows all the MUTCD guidelines, but after we ran about 30 participants on this street, we found that no one looked at the sign. And actually, no one looked at the sign, and then our cyclists sort of failed to make the movements that they were supposed to make, right? And so, you know, Otis found this to be very useful when we presented these results. They said, you know, this really helps us understand the value of striping, you know, where our signs need to be placed or not placed, and when we should use striping and painting, and when we should use signage and so on. So we're just really excited about this sort of new, additional new information that kind of takes the anecdotal to the quantitative. And also, we were able to evaluate the placement of these new bike traffic signals. And, you know, Otis had deployed a few of them, and we were able to tell them, you know, that cyclists tended to look at the traffic signal that was placed here and not here, and so on. And it really brings an additional level of insight. I've also been using this technique for concepts like wayfinding and intermodal terminals. Do people see a sign? Do they take away information from it? Does the sign inspire confidence, or does it inspire stress? You know, just with a deployment partner of the Port Authority of New York and New Jersey, and also SEPTA, and thinking about particular people who are living with disabilities, and how do they wayfind through particularly complicated terminals. Actually, that work with SEPTA is just kicking off now. It's pretty exciting. So I want to, okay. I want to, Joy, is there another question? Good. Okay, great. So this is the sort of safety research, you know, very, very briefly. I'd be very happy to talk about it longer. And I'd like to move into the study. Oh, I'm sorry. Before that, just some other safety-related research we have going on. One is with a partner called Lumos. Lumos makes a very high visibility helmet. And this partnership just opens up a whole host of questions. Does helmet visibility affect driver behavior? You know, what is the value of having a visible helmet as a cyclist, as a scooter rider, as a driver, and so on? And we're working on this with Lumos. This, of course, was supposed to kick off in the spring. We're starting to collect data. We've collected our pilot data already, and collecting more fully fleshed out data. Also working with both Bird and Lime, we're working on developing a learning curve for e-scooting, right? So I mean, not surprisingly, and certainly not statistically surprisingly, most scooter crashes happen on people's first ride, and most people, everyone has to take a first ride, so there's some you know, multiple reasons there. But how can we understand how first-time riders interact with the scooter? And could we make some sort of targeted suggestions, learning platforms, and so on, based on how people ride the scooter for the first time? So we had about 20 people ride an e-scooter, most of them for the first time, and we were able to sort of evaluate how their stress changes, how their eye movements, their head movements, and so on, how this all changes with sort of successive loops around the same location. And also, right now, luckily we did this before the pandemic, we have a brand new protected bike lane facility on Spruce and Pine through Philadelphia, and we had subjects ride the facility with the old bike lane before the upgrade. Then we had the same subjects ride the bike lane after the implementation of the bollards and the paint. So we can actually do paired analysis and see how this intervention, how this safety intervention changed people's behavior. And so I'm really excited about that. I love the idea of this more epidemiological look at transportation intervention. Okay, so now I want to move into the I love mess portion of my research, what really drives me, and that's planning for the unexpected, right? Models to predict and recover from shocks in the transportation system. So we've just seen so many shocks on the left here. This is, you know, one of my sort of first meetups with my students after the after the universities were closed in March, and sort of the widespread awareness of the pandemic. Actually, sort of second down from the left is Dr. Xiaoxia Dong, who's a collaborator of mine, a former student, now postdoc, who we worked on this next paper I'm going to present. But there are lots of other shocks that the transportation system has seen and will continue to see. I mean, the introduction of ride-hail was a huge shock to the system. The introduction of autonomous vehicles, which will be successive and, you know, depend on their price points and so on, right? But the introduction of autonomous connected vehicles, a huge shock in the system. But also things like weather, right? Freak snowstorms and earthquakes and so on, right? Can be these sort of short-term but very dramatic shocks to the transportation system. And how do we evaluate them, and how do we plan for them? And this is something I've worked extensively in, and with one of my doctoral students, who has since graduated, we developed reference class forecasting models for airports so that they could look for their near peers and modify their demand forecasts. A paper that I worked on looked at how airlines choose diversion airports in the aftermath of a shock. The shock could be sometimes airports have been shut down because someone brings a firearm to the airport, or an airport could be shut down because of freak weather or an earthquake or something. And how do the airlines choose where to divert, and how could we influence that choice to really benefit the passenger who's on that aircraft? What I'm going to talk about today is the study of the introduction of ride-hail on travel to a major trip generator. And again, this is with Dr. Xiaoxia, or Summer Dong, who is on the call. Hi, Xiaoxia. And we worked with a deployment partner, the Port Authority of New York and New Jersey, to study what the introduction of ride-hail at the airport and in the broader sort of New York City area, what did that do to the demand and the propensity to travel on AirTrain and on taxi? And these are just critical questions with policy implications, right? The airports rely on taxi flag drops which is like a fee that the taxis pay every time they access the airport. It has major planning implications. LaGuardia Airport is planning a new air train. JFK currently has one. LaGuardia Airport is planning a new air train. Another plug, one of my former students is in charge of that project in LaGuardia, and was very helpful in providing us some data for this study. So the sort of value and the persistence of air train riders or not in the face of ride hail is a really, really critical question. It certainly has implications for environment and congestion and so on. However, it's really hard to model because history doesn't necessarily tell us everything about the future. Again, like this moment right now, what does history tell us about our future going forward from now? And so, Xiaosha and I used a Bayesian structural time series analysis to forecast what would have happened at these airports had ride hail not ever happened, not ever started. This is, to me, just a really compelling method that doesn't require any ride hail data and rather looks at the introduction of ride hail as a moment in time and says, for the sort of pre-ride hail era, what can I learn and what can I forecast from this period? And does my reality match up with my forecast? And if my reality doesn't match up with my forecast, then that moment in time that ride hail was introduced, that was a really significant moment. Now, we have to be careful with sort of causality, right? And you know, Xiaosha and I were very careful to really understand that era, that moment in time when ride hail was introduced, to make sure, you know, it wasn't some other factor, so on. So we do have to be cautious with causality, but it's a really compelling way to look at the intervention of something without actually having the data of that particular shock. So we have this sort of very unique data set of passengers and flights and regional employment and gasoline prices and all kinds of factors that were happening in the New York area at the time. And we used this to predict taxi trips, drop-off and pick-up, air train ridership, and also paid parking spaces. And the data we don't have and we don't really need here are Uber and Lyft ridership and vehicle trip data. So what we did here was we took this sort of, in this case, the taxi drop-off data, and we plotted it for the before ride hail era. And then we developed prediction models to sort of explain these data that we're seeing, and then to forecast what the time series should have looked like should the trend have been the same had ride hail not been introduced. And then we can plot the reality, which is what actually happened to taxi drop-offs, what is the actual time series of taxi drop-offs after the introduction of ride hail. So the dotted line with the gray, that's our prediction. Should we be following the time series before? And then the solid line under that gray is the actual. And you can see that the solid line, the reality, is way outside of the confidence interval, right? So we were really able to show that something occurred. And something occurred in late 2014, which was likely the introduction of ride hail, that sort of fundamentally changed the number of taxi drop-offs at both JFK and LaGuardia. Now, interestingly, when we did the same exercise for air train ridership, we found reality to match up very well with our prediction. And right, so the transit ridership kind of held steady, right? So one of our takeaways was that the introduction of ride hail really pulled from taxi trips and didn't pull as much from air train trips. Now, it's possible that had air train not been introduced, ride hail not been introduced, air train would have seen some big spike that we'll never know about, but the air train ridership trend from 2004 to 2018 is pretty consistent, even with the advent of ride-hail, right? And so we're seeing air train ridership to be very stable. And so, we think that the policy takeaways are very significant. As LaGuardia Airport considers a new air train, this result really helps plan for shocks. But also, I think this method is incredibly compelling for studying changes in time series, the influence of a moment in time. And so these are other things that Shasha and I continue to work on, looking at new airport policies, mega regional travel policies. One could look at airport marketing or new intercity bus lines, right, and what their influence is. And just sort of identifying if that moment in time serves as an inflection point, and that shock really sort of changed the system, right? And we think that this is really compelling. Certainly, this method could also be very useful for the moment we're in now. I mean, I think there's no question that we're in a shock, but one could kind of play around with the time series in order to see if and when we achieve recovery by collapsing or expanding a time series. And I think that that's sort of a really compelling way to look at the impact of the pandemic on travel. And finally, I want to talk about integrating air transportation into system-wide intercity travel models. And I'm going to start with a little bit of a story based on a lot of my previous research, and then move into some of the questions I'm really wrestling with now. Sort of early on for me, in 2013, 2014, 2015, I really became interested in the idea that airports are competing across the United States for air service. Airports are competing for passengers, and airports are competing for federal investments. But that their competition, it doesn't really reflect or account for as much how people in the United States are actually making travel choices. And this is a real motivation. And this study started actually with my first doctoral student, Dr. Amber Woodburn. And what we did was we looked at airports, master plans, and environmental impact statements about needing to expand. And what we found was that most airports in their environmental impact statement, basically everyone but Boston here, their environmental impact statements were very, for lack of a better way to say it, very boostery. Not necessarily about the operations, but really about needing to build a bigger airport, needing to hold on to a hub carrier, needing to be a world-class city and a world-class airport. And for me, this was a real moment to say, that airports are using a lot of federal and local money to expand with the sort of promise of economic development, but not exactly having that be sort of a proven perspective. And also, there's only so much of the pie, right? And sort of all of the airports are trying to compete for it. And I became very interested in this idea of airport competition. I think that this is something that people in Pittsburgh and Philadelphia understand very well, right? In Pittsburgh, you might even have competition with Cleveland and with the other airports in Ohio and Philadelphia. We have Trenton. We have Newark. we have Baltimore, we have a large airport competition as well. So we became very interested in this. And also in thinking about how airports position their expansion, right? And that major hub airports like Atlanta and Charlotte and Chicago, they're trying to expand so they can be the biggest hubs possible. Atlanta's competing with Frankfurt and London, right? In order to get large international traffic, whereas airports like St. Louis and Cincinnati and Cleveland, they're trying to expand to attract air service, elevate their city a little bit, and sort of compete with the other airports in their broader region. And what this led me to was this sort of relatively new concept of airport incentive programs. And what airport incentive programs are that starting in the early mid 2000s, 2000, 2006, 2010, the FAA started, the Federal Aviation Administration started allowing airports to take any unused money and use it to waive fees and pay for marketing programs for airlines to launch new services. And from a scholarly perspective, this had not been looked at, but was, I want to say, understood but not widely talked about in the sort of airport community. And I thought, well, this is sort of an economic development, strategy, right? That should be evaluated for how it's serving passengers, right? How it's serving mobility, how it's increasing mobility. So some of my students and I sort of pulled all the data that we could get on air service incentive programs from the largest airports. And we found that some of the largest airports in the United States have incentive programs where they'll waive fees and pay for marketing programs for airlines to launch new routes. The color is just for international or domestic or both. You see most airports have sort of both programs. The programs are quite nuanced. I'm happy to sort of talk about that. But in general, they waive fees and they waive fees that the airlines would pay, and they'll pay $500,000 or more for marketing programs for the new route, right? So they can be a significant amount of money. While there's quite a bit of sort of methods, data collection, modeling behind this, the takeaway from my studies were that these airports that I'm highlighting here, they spent about $170 million on air service incentives. I should say they spent and waived, right? About $170 million on air service incentives in this period from 2012 to the first quarter of 2015. And sort of interestingly, on 40% of the routes weren't retained when the incentive ended. All right, which means that this was a very sort of short short route, short time frame route that really only persisted because the airlines didn't have to pay anything beyond their operating costs, right? They didn't have to pay any airport fees, and the airport was paying for marketing for them. And to me, there are a lot of takeaways from this, but one of the key takeaways is that the passengers didn't really want these flights. Right, the flights weren't serving a need for the people who live in the area served by a particular airport, right? So for 60% of the routes, they were able to be sustained by authentic passenger demand, but 40% of the routes weren't. And I only looked at a year after the incentive period ends, so should I go back, should I go to look, right before pre-COVID, we may see that, even a larger percentage of routes aren't still operational, right? So this really made me think, we're planning airports, we're investing in infrastructure, we're investing in infrastructure, we're letting airports take their additional funds and use it to invest in the airlines. And this is happening in a way that's not really representative of how travelers want to travel. Also, the planner in me deeply cares about this, because as an aside, the money that's used for air service incentive programs used to be able to be used for sort of city or urban programs, scholarship programs, film festivals, citywide festivals, after school clubs. Like in Philadelphia, we have a after school partnerships initiative, which runs, chess after school programs in the public schools, right? This is something that the airport could actually used to be able to fund with this money. But then once the FAA said, well, also you can use it for incentive programs, and you can't use it for community, you can't use it for community spending, all of the airports, that was basically the only tool in their toolbox. And so the planner in me really wrestles with that policy. So this really motivated me to think about, well, why aren't people choosing these flights, and how are people choosing these flights? And you may be aware of a very long history of literature in transportation on multiple airport system choice. So if you live in the Bay Area or Los Angeles, you live in a region that has a number of airports sort of within a 30-minute drive. And we call this a multiple airport system. And basically, the airport catchments overlap. And what I became interested in researching with my colleague, Dr. Amy Kim, is what is thought of as interregional airport leakage, which is basically, this is me living in Philadelphia going to Newark, right? This is someone in Pittsburgh going to Cleveland. This is someone in Oklahoma City going to Dallas, Fort Worth, right? And the reasons that a traveler might do this are, better flights, more direct flights, cheaper fares, and and so on. And so what my colleague and I set out to do was to sort of model the extent to which interregional airport leakage is happening in the United States across megaregions. And, I thought it was interesting, and I'd love to hear your thoughts on this. When we were discussing this topic, in some circles, people questioned us if this was really a widespread phenomenon, and sort of beyond the anecdote. And, people don't really travel far for airports. However, I'd also had airport directors of smaller airports say to me, I estimate that I lose 400,000 travelers a year to the major airport that's a 4-hour drive away. And so we knew there was something there that really had to be captured. And we sought to do some initial modeling to really sort of capture that. Just to provide some sort of characteristics of airports in their surrounding areas. We looked at Atlanta in the south, and we looked at the airports that surround Atlanta. And we showed that, the airfare in out of Knoxville and out of Chattanooga and out of Huntsville can sometimes be 40% higher than airfare for this to the same destination out of Atlanta. So there really is a reason, for people to drive far to access a distant airport, right? And save money. And actually, I argue that sort of, I don't want to say post-COVID, but, post this moment, people may be more airfare sensitive than they ever have before, and that these airfare discrepancies are really important. So, what we did was we looked at mega regions across the United States. We looked at Phoenix and Dallas and the Charlotte, Piedmont mega region, and the, we looked at the Piedmont Atlantic mega region. We looked at Atlanta as a hub and Charlotte as a hub. And we looked at and modeled travelers who are close to all of these smaller airports like Knoxville and Savannah and Birmingham and so on. A person who lives close to that airport, if they're going to a particular destination, what's the likelihood they would choose their local airport, and what's the likelihood that they would choose Atlanta? Right, and we pulled all the data from the Bureau of Transportation statistics on airfare and flight statistics and frequency, and all of these different characteristics, and also characteristics like the driving distance to the local airport, the driving distance to the substitute, the sort of major airport, and so on. We collected all this data and we did some sort of simulations and sampling from established discrete choice models of airport choice across a mega region. So we have different models that capture the choice of choosing between, for example, direct air service at your local airport and direct air service at your substitute airport. Then we have a separate set of models for choosing between direct air service at the large hub airport and connecting service from your local airport. These models are a function of airfare, frequency, ground access distance, travel time, and so on. The coefficients have been estimated in the literature. We did a lot of sampling to put bounds on our problem rather than sort of picking one coefficient. And we developed sort of spatial choice models that explain a traveler's propensity to take a long drive instead of going out of their local airport. And when we did this in a sort of static way, assuming that somebody lives about 30 minutes from a local airport, like 30 minutes from Birmingham, 30 minutes from Huntsville, and that they're going to Atlanta, we found that the passenger numbers that we estimated, for example, that live close to Birmingham and would drive to Atlanta, is between sort of 300,000 and 700,000 passengers per year. Now, this is very consistent with what airport managers have told us, and we were able to, empirically show this, and also sort of simulate things with the coefficients. So, for example, we were able to simulate. We were able to sort of simulate having different concerns for airfare and ground travel time and so on. The results were fairly similar, but we were able to really put a number on the number of people per year who are traveling, from a smaller airport to a larger airport on the ground in order to take advantage of better service. This was something we had a lot of fun with, which was that we picked points along the highway and estimated what % of traffic could be attributed to people accessing a larger airport. And we found that it's sort of between 1 and 2.5% at most points. Some of these low traffic points are quite rural. But 1 to 3% of traffic is this very significant amount of traffic, right? California is always trying to reduce, VMT by 1% and so on, right? 1% of 1% of traffic at a particular point is a very significant amount of traffic. And so we thought that this really provided justification for integrated air highway planning. I only have a few moments, so I'm just going to mention right now, Dr. Kim and I are doing a spatial implementation of our model. So we're going census tract by census tract, using census tract data to estimate people's likelihood to travel out of a particular airport when going to a particular destination. So we're really happy to be, it seems like some of the initial people in the United States who are showing that airport catchment areas or airport sheds are dependent on not just the destination a person is traveling to, but also the landscape of airport competition in an entire region, right? Again, sort of very traveler focused. We're very excited about that. So I think this has a lot of takeaways for, mega regional travel trends, and really mega regional travel trends, and really making sure that individual travelers, their preferences, and the range of options that are available to them are accounted for in planning. Also, with the advent of new vehicle technology and automation, we're certainly looking at a change in the way people travel in an intercity way. I often get the question of, well, what does this mean for, COVID and intercity travel? I don't think we know the calculus of how people will feel safe, in smaller airports and larger airports, with direct flights, with connecting flights, in their own cars, or so on. But I think it's a question we have to keep our eyes on very, very strongly. Why I study this is because, before COVID, I used to think about, well, what if we only have a few airports that are kind of overrun with passengers and flights and congestion, and a bunch of other airports, smaller airports especially, that are empty. This was doomsday. Somewhat it is today. And again, I think it's something that we need to keep our eyes on. With that, I will wrap up and say thank you to my collaborators who I mentioned, and thank you all for listening. I'm really looking forward to discussion.
Hi, Megan. It's Lisa Kay, and I want to thank you so much for your presentation today. Unfortunately, I don't think we have time for questions, but I looked at some of those charts and I was like, wow, never saw the information put together that way. So thank you so much for joining us today, for sharing your research. As I mentioned earlier, today's presentation has been recorded. Once the recording is done, we will be posting it on the Mobility 21 What's Happening page, along with a link to the video. This afternoon, you will also be receiving an email asking you to take a short survey about today's Smart Mobility Connection session. Please take a few minutes to give us feedback. It does help us as we're planning for future sessions. For students who are interested in engaging in transportation topics in Pittsburgh, Pennsylvania, the Carnegie Mellon University's Transportation Club is on campus and is a great way to plug into transportation topics with all the fellow transportation nerds. And we will be having our next Smart Mobility Connection seminar on Friday, September 25th. And our featured speaker will be Dr. Corey Harper, and he will be speaking on advancing towards a smarter and more sustainable transportation system. Dr. Ryerson has said that we can forward out her email, so we will do that in the follow-up. So if people have additional questions, she would be willing to answer those. So thank you, that's really nice. Again, thank you for attending today, and feel free to contact us with any questions. Have a great rest of your Friday.